Some of the important points I've listed here. Okay, usually it is a compound between metal and a non-metal. It will possess both the properties, some of the metal properties, some of the non-metal properties. Okay, so it is a compound between metallic and non-metallic elements, and it is always composed of more than one element. It is like a composite thing. For example, sodium chloride, SiC, SiO2, silicon carbide, silicon dioxide, etc. More than one or two elements will be mixed with it, right? So bonds, either in any material we see either the ionic bonds or covalent bonds, but here ceramic property is that bonds are partially or totally ionic, and sometimes it might have combination of both covalent as well as ionic bond. What is this bonding? We will not go in detail, right? And they are brittle in nature generally. I have told you the difference between a brittle structure and a ductile structure in the last class. Okay, ductile structures don't break at one point. Usually, initially they start deform, right? Like metals. Okay, when you keep on applying the load, at some point where the threshold is reached, they fail. But brittle materials don't deform. At once they fail. Like your car glass. Once there is some hit, there will be a crack, it fails. But whereas the same hit is for the body, there will be some dent which you can remake it. So that is the difference between ductility and brittle nature. So this is very brittle in nature. Because of brittleness, see wherever the materials are brittle, you cannot process it easily. Even in the process of fabrication, little bit more load, the material can break, right? So even though it is brittle, it is having higher hardness. It can take a lot of load, right? They are good insulators of electricity and thermal, that is heat and electric insulation is good. Okay, they are very highly chemically stable. Even though you bring in contact with acid, it will never react, right? And they can be optically opaque. They don't transmit light. They are semi-transparent. Okay, or sometimes you can design it as a transparent one. So these are some of the unique characteristics of ceramic materials. We prefer it over other materials like metals which are readily available. They are all fabricated materials, whereas metals are available directly in the nature. Okay, so advantages: harder than conventional metals, right? Ceramics are definitely, even though they are ductile, they are very much harder. Okay, low coefficient of friction. Friction will be very less when you use in moving parts. Okay, extremely high melting point, so they will be resistant to heat. Okay, as we studied in the earlier slide, they can go up to 1500 degrees centigrade. Okay, their properties won't be lost. Okay, corrosion resistant. Okay, low density, that is light in weight. Okay, extreme hardness will be there, and they are very cheaper. Right, any ceramic pots or ceramic tile, etc. If you take, they are much cheaper compared to other materials, and they are easily available. Okay, glazed ceramics, okay, where coating is done, they don't get stained away. There will be no any marks left out, even though you pour acid on it, right? So these are the advantages. Some limitations are there. Okay, it is very difficult to maintain the dimensional tolerance. Okay, there is a process called as machining. In module 4 we will be studying, we will be using some equipments like lathe. Okay, say for example, if you want to fabricate this, okay, you need certain structure to be done using some machineries, correct? So if you take two of the legs of this stand, there will be some prefix dimension. If this leg is larger than this, okay, it's of no use. You cannot use this table for the intended purpose, correct? Okay, so there is a word called as precision. If the rear leg height is fixed, exactly it should be of same height. If front head legs are fixed, it should be of same height. Then only you can use it as a podium, right? So such dimensional tolerance can be maintained exactly in metals and non-metals, whereas this tolerance maintenance in ceramics is very difficult. If you ask why, it is very brittle in nature. If you apply more load to make it to the exact dimension, it will break in the process. Handling will be difficult. That is one of the biggest problem. They are weak in tension. They are definitely, they can take up more compressive load. You press it more, it can take up. But if you apply the tensile load, they cannot take up much. So wherever tensile load is to be applied, wherever tensile environments are there, we cannot prefer usage of ceramics, right? Poor shock resistance. Suddenly there is some bump. Okay, they cannot resist. Whichever material is brittle in nature, it cannot take up. Simple example, you are driving your car at 80 or 90 km/h. There is a truck in front of you with a small stones in it. One of the stone comes and falls on your bonnet. What happens? If the hit is lighter, only there might be a scratch, or the stone size is larger, velocity is more, it may get a dent, which you can easily resolve it at a lowest cost. Correct? If it is a brittle glass material, a small bump on it, suddenly there will be a crack. Day by day, that crack keeps on growing. There will be a permanent deformation. You can never repair it, right? Wherever brittle nature comes, this shock absorbance will be very poor in nature, right? It can crack when hit with heavy items, which you cannot repair. Whereas metals or non-metals, whatever may be the deformation, you can easily repair it. Okay. So application you will be using for some tableware, sanitary, whatever we see bath fittings these days, right? It may be your commodes or wash basins. Okay, they gave a beautiful look, right? So this material will be used pottery, bricks, whatever we see, tiles, refractory, electric porcelains. Okay, like that. There are many applications. So these are the advantages, limitations, and applications of